thanks everyone for tuning in today again. We're going to start. So today's webinar. So we are very delighted to have you all. So the topic of today's webinar is from chaos to control: how to simplify multi-cluster networking for all of your applications. All right. So what is the agenda for today? So first we are going to give a quick introduction of ourselves, and then we are going to review what are the multi-cluster challenges associated with running and managing a multi-cluster setup in regards to the to the networking. We are then going to check what are the different options that you have in order to manage those multi-cluster routing. We are going to see the pros and cons of the different options, and finally we are going to explain you how you can actually tackle that challenge using Traefik Enterprise and Traefik Provider, which is the feature we're going to use in order to do that. And finally, the interesting part of the session, we are going to have Matt demoing that solution in live, and we will show basically how you can manage easily a multi-cluster networking setup. Great. First, let's have a quick introduction. So my name is Adrien Martinet. I'm the head of sales at Traefik Labs. I joined the company 3 years ago, and I would have the pleasure to be with my colleague Matt today. Matt is a solution architect based in the US on the East Coast. I am based in Europe, and Matt is responsible for the solutions architecture here at Traefik Labs. So mainly engaging with customer, doing demos and design session in order to validate the architecture, the future architectures of our customers. So before starting and speaking about the challenges associated with the multi-cluster, just a few words on the on Traefik Labs. So Traefik, everything that we do at Traefik Labs is really focused on open source and on open source products that are very simple. Simplicity, automation, cloud native, these are keywords for us at Traefik Labs. So the flagship product of Traefik Labs is Traefik Proxy. This is a famous load balancer or reverse proxy that has more than 2 billion of downloads today, more than 600 contributors. So definitely a very, very interesting product that you might know already. And we have some leading companies such as eBay or Expedia using Traefik on a daily basis in order to send the request to the right containers or APIs. Okay, so let's have a quick view now of what are the multi-cluster challenges associated with multi-cluster networking. All right, so the first one that we can mention basically is that some customers are used to get a certain container platform for a few years. Back then, some of them were using Mesos. We had a few users and customers, running Docker Swarm still, by the way. And obviously, we can safely say that Kubernetes has won the orchestration war in regards to containers. So now many people are deploying Kubernetes clusters, whether it's in the cloud with the traditional, GKE, AKS, and EKS services, for example, in the different Google Cloud, Azure, and AWS vendor. And we also have some customers running OpenShift, VMware Tanzu, and Rancher on premise, for example. So we see a multitude of different Kubernetes deployments, and we received that feedback that it was quite hard for some people to still manage the existing, I would say legacy, if not, I know it's not the real legacy, but the existing Swarm clusters and the existing Kubernetes clusters aside, because you quite often have two teams that are publishing the services in those two different clusters. And it can be hard for the networking team or the security team to understand exactly which service is published with what type of configuration and with which security level, so to say. I've already touched on that, but the migration from one platform to another is certainly, a challenge for these companies. So they must make sure to move either the existing services or new services to Kubernetes, for example, and at the same time they must have like a clear view of which service is alive on which platform at any moment, and that's what we have seen most of the time. Matt, what are the other challenges that you have seen in regards to managing multiple containerization platform?
Yeah, so on top of the things that you've already mentioned, so really what a big part of the challenge boils down to is that with the existing approaches that can be used for routing across multiple clusters and orchestration types, there is going to be some level of manual configuration. So that poses a challenge because philosophically, it kind of goes against the cloud native approach where everything is automated and you're doing service discovery in your clusters. But it also introduces a lot of risk for configuration errors. If you have a syntax issue, you could introduce some sort of challenge on one of your clusters or in your entire infrastructure. So that manual config can often pose a big problem for these types of complicated multi-cluster scenarios. Adding to that complexity, the reality of most of the companies we work with is that not everything is cloud native and running in Kubernetes and fully orchestrated. Most companies are going to have some sort of legacy virtual machine based workloads that are still running alongside these containers. So having to account for routing across these different clusters, these different types of orchestrators, while still handling those legacy VM workloads just further raises that level of complexity. So what we want to do now is, with that challenge framed, we want to quickly walk through a few approaches that we've seen for handling this routing across multiple cluster types, and break down the overall architecture and also summarize some of the pros and cons we've seen for each of these approaches. So the first one that we've seen is probably the simplest of the approaches that we're going to see. So for each of these scenarios that we're going to talk through, the common situation that we're going to use is that we've got a couple of different clusters that are running somewhere. We're going to say one is a Kubernetes cluster, one's a Docker Swarm cluster, and each one of those has a couple of different services running. So for example, we've got service A and B in Kubernetes, service C and D in Docker Swarm. We've got an ingress running in each one of those that's handling incoming requests, proxying them back to the correct service based on some sort of logic. So that pattern within the clusters themselves has been pretty well established, and that is largely a solved problem. But outside of that, it can start to get more complex. So in this particular approach, the way that we've seen customers route across these different clusters is through simple DNS entries. So you've got a DNS provider that you are maintaining A or maybe C name records pointing to the addresses of these ingress instances for each of your clusters. So relatively straightforward. You've got a record for maybe cluster A.example.com routing to Kubernetes, cluster B.example.com routing to Docker Swarm. So the main benefit in this type of scenario is that it's relatively simple. There are fewer moving parts to have to deal with, to have to worry about maintaining the configuration. But there are a lot of challenges that are presented with this type of approach. So the main one is that it's kind of at odds with that cloud native ecosystem where a lot of times your IP addresses are dynamic. If they're in the container world, they're updating frequently. And updating those through DNS can be problematic, especially when you start to account for the lag that can be associated with those DNS entry updates. it runs into reliability issues for being able to quickly update your configuration in your routing. The other challenge that we see is that this will drive some design decisions for how you're routing across clusters, and namely, if you've got non-identical sets of services in these clusters. So like in the example we're looking at where we've got service A, service B in one, service C, service D in another, we're going to have to manually call out which router or which cluster rather we're routing to from that first layer router. So that's going to impact how we design our API endpoints as well. So let's go from there and look at another example. So in this case, we are using the same general framework. We've got the same routing strategy, but we've added an additional component here where rather than routing directly via DNS, we've got some sort of edge reverse proxy that is layered in front of these ingresses in the clusters themselves. So same logic is being applied. We've got cluster A and cluster B that we are routing based on the host name to these individual clusters. But the difference here is that we've now got this reverse proxy that is handling that, that is then being pointed to by most likely some sort of wildcard DNS entry to this proxy instance. So in this case, we have some benefits to the approach. The main one is compared with the previous approach, the changes are going to be more immediate than if we're trying to manipulate these updates through DNS entries. The other benefit is that this is a relatively simple configuration that we have to maintain at the this edge reverse proxy instance. So we've got a single line item of configuration for each of the clusters that are attached. But there's still some challenges. So we still have to use that grouped by cluster routing for our routing endpoints. So for that reason, we can't expose a single API endpoint like maybe api.example.com. And beyond that, the configuration still is manual. We're still going to have to maintain this both at the lower level and at this, this new edge reverse proxy level. So let's wrap up this section with a third scenario where we've got the exact same architecture that we were looking at before, where we've got DNS pointing to a reverse proxy at the edge that's then routing to the ingresses in each of the clusters. The difference here is rather than routing by the cluster name by host name, we are maintaining a list of each of the individual services and where they are currently located at the reverse proxy layer. So for example, we know that service A and service B are running in this Kubernetes cluster. We know service C and service D are running in this Docker Swarm cluster. So we've got those routing rules listed accordingly at the reverse proxy layer. So the main benefit to this approach, as compared to the other ones we've talked about, is that this allows for a more flexible approach to our routing across the clusters. And namely, that means that we don't have the same challenge and we can expose a single API endpoint, say api.example.com, to route to these multiple clusters. The challenges here, though, mainly stem from the fact that your configuration on this edge proxy layer starts to get pretty complex, especially if you are, operating at the scale of not a couple of services per cluster, but tens or hundreds. That can get very complex very quickly. That introduces a higher risk for configuration errors. If you've got to maintain what's running where at that edge proxy layer, that can get pretty risky pretty quickly. And finally, when you start to look at this in the context of some sort of migration activity, say from Swarm to Kubernetes, that requires a ton of planning that you're going to have to figure out both in the cluster itself and making sure that you're coordinating these routing rules across all layers of your infrastructure as well. So now we're going to transition from the challenges, the existing solutions, and we'll talk a little bit about how we can leverage Traefik Enterprise to automate some of these routing decisions across infrastructures like these.
All right, thanks a lot, Matt. As you can see, we have seen different scenarios, where it's actually quite hard and complex to manage these multi-networking, cluster setup. And we are going to explain you how you can actually tackle that challenge and situation with a solution such as Traefik Labs, the Traefik Enterprise. So the solution itself is based, on Traefik Proxy, which is the open source solution, so the flagship product of Traefik Labs. So it's an ingress. It's also a service mesh. Service mesh is responsible for the service-to-service communication. It's whenever you would like to establish a connection between two pods or between two containers inside a Kubernetes cluster. And it is based on an open source solution that we've developed as well with the community called Traefik Mesh. And we say also that Traefik Enterprise is an API gateway in a sense that it can help you to manage the authentication and the authorization. So basically, you can delegate that to the Traefik Enterprise networking layer. So it's a unified solution for ingress, mesh, and API gateway, coming with support. And we are going to see right now what's the architecture of that solution. Thank you, Matt. So as you can see, so you see on the left, so basically you have incoming requests coming from the internet to your cluster. So Traefik Enterprise is both a layer 4, so TCP and UDP, and a layer 7 reverse proxy. Layer 7, so basically you have HTTP, HTTPS, gRPC as well, and WebSocket. So you can manage all these types of incoming requests to the cluster. Basically, it's going to hit a first level of load balancing, right? And then it's going to go to the Traefik Enterprise cluster. As you can see, in Enterprise, you have the controller. The responsibility of the controller is to auto-discover the services. So the controller will have a direct connection with the orchestrator API. Let's take Kubernetes, for example. So it will constantly ask to Kubernetes, what type of services are actually deployed, whether you are using the Kubernetes CRD or the Kubernetes ingress route as a way to declare your services. Once those services are called by the controller, the controller will update the ingress proxies, and this is actually the components who will take the incoming request and send them towards the right backend. So with this distributed architecture, we're able to have some distributed features such as distributed certificate management with Let's Encrypt, for example. We are also able to have the distributed rate limit. And as you can see on the screen, in the middle, you see load balancing, Canary, and mirroring. You can add some different load balancing methods in order to send the request to the backend. So that was, in a nutshell, the quick presentation of Traefik Enterprise. Now Matt is going to show you how you can actually automate that with the traffic provider features, which is actually new in Traefik Enterprise 2.5.
Thanks. So let's jump into this new feature and how it relates to everything we've been talking about so far in terms of the challenges and the existing solutions for multi-cluster routing. So this diagram that we're looking at is an example of how we can use a new feature called the Traffic Provider that's been introduced in version 2.5 of Traefik Enterprise. And basically what this allows us to do is to automate away a lot of those challenges that we just walked through for each of the existing solutions for this type of multi-cluster routing. And the way it works is that if we start to break down our original example framework for these multiple clusters, so if we have a couple of clusters, one Kubernetes, one Swarm. In Kubernetes, we have Traefik Enterprise running as the ingress controller in Kubernetes. It is talking to the Kubernetes API to do service discovery. In the Swarm cluster, same thing. We've got Traefik Enterprise running as the ingress for the Swarm cluster. It's talking to the Docker API to do service discovery there. And then we're also introducing this third layer of Traefik Enterprise that is running at the edge here in front of both of these clusters. And basically, rather than having to manually maintain that list of routing either by cluster or by service like we saw earlier, this Traefik provider allows us to point to the API on each of these lower level clusters and automatically sync that dynamic configuration up to this first layer. So basically, once we set all that up, we're able to have this first layer of Traefik Enterprise automatically route incoming requests correctly to Kubernetes or to Swarm based on this underlying configuration without having to do any of that manual updates to the configuration on this first layer instance. So we can take a look at exactly how that works from a configuration perspective before we dive into a demo example. So we'll walk through the configuration that's required on both layers. So first, we're going to look at the layer 1 config, so our edge proxy that's doing the routing to the individual clusters. So in this case, the important thing that we need to look at here is this providers section. So you can see here, we've got this new Traefik provider line item that we're including. And basically, we're going to declare an instance of this Traefik provider for each of our underlying clusters that we want to sync the configuration from. So in this example, we would have one for Kubernetes, we'd have one for Swarm. And basically what we need to do is point at the API address of those lower level Traefik instances. We also can include an authorization header field, which is obviously a best practice. If we're running this in production, we want to make sure that we're securing those calls to the API. And in this case, we'll be doing it with the API key authentication middleware, which is another new feature that's been introduced in version 2.5 of Enterprise. So next, let's look at the configuration on those layer 2 instances. So these will be the Traefik Enterprise clusters running in Kubernetes and Swarm in this example. So there are a couple of pieces that we're going to set up here that are important. So on our static configuration for these, we need to enable the API so that we can pull that configuration up to the layer 1. Here, we're going to expose it on a dedicated API endpoint that we're exposing on port 8080. And secondly, in our dynamic configuration, we're going to set up an API router so that we can access it from layer 1. So in this case, we've got this API TLS router that is exposed again on that API entry point. We're using our API key authentication middleware to protect that endpoint. So you can see here, we've got that set up as a middleware here, where we are giving it a secret value that's going to be stored in our authorization header to make sure that we're able to make that call securely. We're pointing at the host for that individual Traefik Enterprise instance that we're going to pull that API from. So before we dive into a quick demo of how this works all put together, we did want to touch on a quick customer use case just to give an example of how this type of infrastructure is being leveraged in the real world. So this particular customer is a large mortgage company with a particularly complex infrastructure. And specifically, they are routing services that live both in Docker Swarm clusters and Red Hat OpenShift clusters, with migration eventually planned from Swarm over to OpenShift. And what they've been doing is leveraging this Traefik provider inside of Traefik Enterprise to simplify that routing across that entire infrastructure. So basically being able to leverage the auto discovery in both of those container orchestrators while still having a unified point of entry with the Traefik Enterprise with the Traefik provider on the front end. So like I said, let's now dive into a quick demo here. So a quick summary of what we're going to be looking at in this demo. So we'll be, from an architectural standpoint, running through exactly what we've been talking about for this whole presentation. We'll have a layer 1 instance of Traefik Enterprise that is running on a virtual machine. we've got a couple of layer 2 instances, one that's running in Kubernetes, one that's running in Docker Swarm. And basically, we're going to set up that traffic provider to make those calls securely with the API key middleware. And then we'll wrap up after walking through that configuration by simulating a migration from Swarm over to Kubernetes and see how we can do that seamlessly with the provider without any sort of downtime. So what we'll do here is jump over from our slides over to our enterprise dashboard that we have here. So you can see here, what we're looking at here is our layer 1 instance of Traefik Enterprise. So this is that edge reverse proxy that's routing to the individual clusters. And you can see we have a number of routers that are being consolidated and exposed here on this central instance. So the one that's actually being defined on layer 1 is just the router for this dashboard that we're looking at, but everything else we're getting pulled from those layer 2 instances in the clusters. So you can see we've got corresponding API endpoints for both Swarm and Kubernetes that are being pulled from those layer 2 instances. And similarly, we've got a couple of services using the Who Am I app that are running, again, respectively, in Swarm and Kubernetes clusters. So we can see an example of how those are running if we take a look at our tabs here. So /whoami, we have a whoami on Swarm instance running. And same thing, /whoami-Kubernetes, we've got whoami on Kubernetes running. So with that being shown, let's now jump over to a code editor and we will take a look at how we have all of this set up from a configuration perspective. So I want to walk through the layer 1 config, then we'll talk about the Kubernetes and Swarm config before showing that migration use case. So layer 1, we're looking at our static config file that we've got here. And again, the important thing that we're going to be looking at here, aside from the standard entry points that we have exposed here, is we've got our traffic provider set up in our providers section. And just like we mentioned earlier, we've got 2 different instances of that provider. We've got one for Kubernetes and we got one for Swarm. Each one of these, we are pointing at the address where that API for that Traefik Enterprise instance is being exposed. So Kubernetes and Swarm, and then we are leveraging that API key authentication middleware to secure that call to the API endpoint. Let's now jump from layer 1 over to layer 2, and we'll look at our configuration on the Kubernetes cluster Traefik instance. So the important thing to call out here is, again, that we are exposing our API entry point and we're enabling our API. We're using the Kubernetes CRD provider to actually discover the service that's running in our cluster here. From the dynamic config side of things, we are creating an ingress route for our API. So basically matching at Kubernetes /API is going to match to our API internal entry point, again, leveraging our API key auth middleware to secure that call. So we can quickly look at our Swarm config to round out this discussion. It's going to be very similar to what we saw on the Kubernetes instance, where we've got an entry point for API enabled. We've got the API actually being exposed as well. And then we've got the Docker provider set up to do service discovery. On the dynamic side, exactly the same as what we saw for Kubernetes. We are setting up a router for our API at the Swarm /API URL with the API key authentication covering it from a security perspective. So let's next take a look at our definition of our routers for the services themselves for that Who Am I application, and then we'll talk about how we can simulate a migration here without any sort of downtime or manual updates on the layer 1 instance. So we'll look at these files here where we've got a Who Am I service deployed as a Kubernetes deployment. In front of that deployment, we've got an ingress route that is setting up a path rule to match on that who am I Kubernetes. The other thing to call out here is that we have our priority explicitly defined here. So we've got our priority set to 1 in this example here, and this will come into play when we take a look at our migration use case in a second. On the Swarm side of things, we've got the same application deployed as a Swarm service, and we're leveraging the Docker labels to set up our routing. So here we've got path/who am I is matching here, and we've got our priority set to 2 here. So priority is set higher than the Kubernetes instance currently. So what we want to do now, so we've got, again, both of these examples running, and we're going to focus in on this /who am I path for the sake of migration. So let's say in this scenario that we have this who am I application that's been running as a Swarm service, but we want to migrate it over to running in Kubernetes instead. So we've done the deployment over to Kubernetes. We have it running in parallel, and we want to update our routing rules seamlessly. So what we're going to do for that is we'll jump back over to our page here, and we are going to update our who am I definition. So the first thing we'll do is we're going to consolidate our routers here. So we'll save that and apply. So what we should see here now is that rather than having that separate who am I -Kubernetes route, we're going to have both these exposed at /who am I. So we'll jump back over here, and we should see now we've got both of those services defined at the same path. And we're seeing that we still get the Swarm version of our deployment that is resolving on who am I. And that's because we've set our priority value higher on Swarm than on Kubernetes. So what we can do next, and let's say that this is after we have deployed this over to Kubernetes and we've done all of our testing to validate that things are looking good on the instance of the application in our Kubernetes cluster. We're going to update this file one more time, and we're going to update our priority to 3 so that it's higher than our Swarm priority. So we'll update that, do a kubectl apply one more time. And what we should see is if we give it a second here and then refresh, we're now getting the Kubernetes version on that /who am I endpoint. So we've been able to seamlessly orchestrate that migration across our orchestrator types without having to do any sort of manual configuration on that layer 1 instance that's consolidating that routing across our multiple clusters. And we're able to kind of use that flexibility of exactly how we want to use our routing strategy, whether that's path or host name, and are able to seamlessly handle that migration over. So at this point, we have run through the challenges that are posed with multi-cluster routing. We have run through some of the existing approaches and the pros and cons that are present there. And then finally, we've walked through the approach through the Traefik provider with Traefik Enterprise to automate some of those challenges away and provide a seamless way to orchestrate that multi-cluster, multi-orchestrator type routing across all of your infrastructure types as well. So now we'd like to open it up for any questions that you may have about the presentation.
Thank you very much, Matt. That was definitely a great demo. So we see a few questions already on the Q&A section. So thank you very much. Don't hesitate to bring more questions. We have one question from Nicola. Can a L1 instance reference itself and be used as both L1 and L2?
That's a good question. It is not something that I have tested out yet. I would be curious to know what the use case for that would be. I think it's possible that you would, run into some sort of circular dependence there. We would have to check on exactly how that would work. But if the use case is what I'm guessing it would be, and that's to be able to leverage configuration on both the layer 1 and layer 2 instances. One thing I can add is that you can use this traffic provider alongside your standard traffic providers that are available. So if you are also routing based on a KV store or on the file provider to other instances, you wouldn't necessarily have to reference itself through this traffic provider approach, and you could just leverage traffic provider for that layered cluster approach alongside just using the traditional traffic providers that are available.
Right. We have another question. Why are you using Vagrant? Apparently, someone has helped us in the answer here.
Oh yeah. So good catch. So Vagrant was used to set up the local demo environment. Obviously, because this is meant to be used in the way that you are routing across a distributed system in the cloud or across data centers, Vagrant was used to set up a few local virtual machines so that we could set up the discrete instances of traffic in Kubernetes and Swarm on that layer 1 instance as well.
Great. I have another question, Matt. And for those who don't know, first I need to define what is a middleware. A middleware in traffic vocabulary is a way to tweak or modify the incoming request going to the backend. For example, a middleware could be a compression, a circuit breaker, a rate limit. This is what we call a middleware. So now the question is, how are middlewares handled on each layer? Because now we ultimately have like a layer 1 with the traffic provider first, and then it goes to the layer 2, which is the either Swarm or the Kubernetes traffic layer.
Yeah, great question. So the way that the middlewares are currently handled in this sort of setup is that the middlewares will take effect on the layer 2 instances. So if you have middleware set up in your Kubernetes or Swarm providers, that is where they'll actually be executed. And basically when the configuration is synced up to the layer 1 instance, it is syncing the routing logic, but not the actual middlewares. And that was done for predictability and for simplicity, that basically you'll be able to route from layer 1 to your layer 2 instances. And then there you've got your middlewares that have been defined that will behave as expected.
Yeah, very clear. Thank you, Matt. Then we have a question from Luigi. What happens if we set the same priority to Kubernetes and Swarm service?
Yeah, that's a good question. So I believe in that scenario, then you would run into the default priority behavior for traffic routing. So it's something that we could test to see exactly how it would be handled. But basically the idea would be that you would coordinate those priority levels so that you are intentionally setting one higher than the other. And then aside from that, you would be making sure that you're avoiding any sort of path conflicts, unless that path overlap is done intentionally for that migration use case to have those individual priorities be toggled to have that cutover happen.
Yeah. Thank you. Another question here, more generic question. I guess, how to find the right and fitting routing strategy for an application?
Yeah, that's a great question, and probably one that doesn't have a one size fits all answer, because it is so dependent on the application and the overall networking setup of the entire, networking stack for that organization. I think the general answer is that with Traefik, you get plenty of flexibility to set up your routing logic, whether that is by host rules or by path or path prefix, using regex rules, routing by header. So you do have a ton of flexibility on the Traefik side for exactly how you wire up all of that routing logic. But in terms of a blanket recommendation for how you would set that up for an individual application, it's tough to say without knowing, exactly how that application's set up and how you have the rest of your infrastructure kind of interacting with that as well.
Absolutely. And don't hesitate, right? If you have like a specific challenge in mind, that will be a pleasure to review the requirement and think about a potential solution together. We have a question from Patrick. It's good to see you here, Patrick. Thank you for tuning in. What are the requirements for the VM that hosts the first layer of Traefik Enterprise? And the other question is, can you cluster the layer 1 instances for high availability? Is it a 2-node or a 3-node cluster?
Yeah, good question. So we do have some recommendations as far as hardware goes for the layer 1 instance, or just running Traefik EE on-prem in general. So I would have to double check exactly what those are, just to not quote anything imprecise here. But what I will say is that Traefik EE is meant to run fairly lightweight and doesn't require a ton of system resources running on bare metal or VM or in containers for that matter. In terms of the high availability question, yes, so you can definitely cluster those resources for HA, and that's definitely what we would recommend, and is actually the default architecture for Traefik Enterprise. So what this would probably look like in production is that you would have that layer 1 instance would rather be an instance in the sense of being a cluster of Traefik Enterprise, which would be a controller VM, at least a couple of proxy VMs that you have set up for HA for redundancy on that layer as well. And then that same concept would apply for the containers running in Kubernetes and Docker Swarm, et cetera.
So I guess it means that it's going to be a 3-nodes cluster minimum, to have 1 controller and 2 proxies at least. And yeah.
Exactly. Yep. Three or four. 4 would probably be the default that we would see with Traefik Enterprise, including the plugin registry component. But certainly at least a few to set up that distributed architecture with some redundancy built in.
Excellent. I'm looking up at the time as well. It's good. So we have the time to take the other questions. We have a question here. If a new service being deployed to a cluster, will the layer 1 create a route automatically based on a certain rule?
So if a service is deployed to the cluster, will that layer 1 instance automatically detect that, basically? So yeah, so if you are deploying a new service, let's say in our Kubernetes cluster, and you set up an associated dynamic config object for that service. So in Kubernetes, if you set up an ingress route with that routing rule, then yes, that's something that's going to be auto detected and will appear on that layer 1 instance. And that's really the idea, is being able to only manage that config at your, that cluster layer 2 level, and have that automatically synced over to that higher edge proxy layer.
All right. And then there is a Luigi asking, can you make this test in the demo? I guess Luigi would like to challenge you here. And not sure if this is something we can do right now, but.
We could set it up, sure. So here, so if we updated this, whoops, or rather if we updated our file first before we apply it. So basically we want to set this to priority as 2, save that, update our definition. So that'll get updated, and basically what we'll want to check is what resolves on this who am I endpoint. So looks like we're still getting the who am I on Kubernetes. The Kubernetes version of this example, it's being run when the priorities are set equivalently in both of those instances of the application. So what we can do is we can definitely follow up on exactly what's driving that behavior. And if you want to follow up with us outside of this webinar, we'd be happy to make sure we get you, some deeper detail on exactly what's going on if you have that specific use case going on in your routing setup.
Great. So yes, we have time for, okay, let's take 2 more questions. Any example of using Traefik on Azure Kubernetes service with Azure DevOps? Thanks.
Good question. So definitely we see Traefik and Traefik Enterprise being used on AKS very frequently, and it works great as kind of a standard Kubernetes distribution. Traefik and Traefik Enterprise play nicely with AKS. As far as Azure DevOps, I can't say off the top of my head a specific use case where we've seen that being used, but I think it would certainly work well with the GitOps approach that we use for Kubernetes installation. So basically deploying Traefik Enterprise into a Kubernetes cluster, we use a standard set of YAML manifest files that define your resources, your CRDs, your static and dynamic config. So there's certainly no reason that you couldn't hook that up into some sort of deployment pipeline in Azure DevOps and have that automated to update your config in your AKS cluster.
And don't hesitate to reach out for that, because I mean we are a Microsoft partner. So Traefik Enterprise, is on the Azure marketplace, and if you have any, use case, that would be a pleasure to have a look at this use case. And we are working, conjointly with some, Azure cloud architect on different topics with customers. So don't hesitate to reach out for this one. And final question, don't know if it's a question or a comment, it's on the chat section, Matt, this one. A question from Mike. Priority switches the traffic. How about Canary configuration across different clusters?
Good question. So wanting to set up the Canary type deployment across Kubernetes and Swarm. So say that migration use case, you want to switch over 10% of your traffic to your Kubernetes cluster rather than a wholesale switch over all at once. That's a great question. I think currently that would probably fall outside of the use case for the traffic provider. The way that we generally see Canary deploys get instrumented in Traefik is using a traffic service that is going to basically set up the weighting of the traffic across the different clusters. So that's something that you could manually set up, I would think, on the edge Traefik instance, where you have a traffic service using weighted round robin that is pointing specifically to your individual Kubernetes Swarm cluster addresses. But that's probably something that would fall outside of the use case of this traffic provider as it currently exists.
But definitely an interesting question, because since Traefik Enterprise with this traffic provider feature is super helpful for the migration from one cluster to another, you might want to slowly but surely send the users towards the new applications by having some weighted connections to the new cluster. So definitely an important use case. And by the way, we are going to to review these questions and giving you an answer after the session. So that's it. No more question into the QA section. So that's this is great. So we are going to post the link of the trial of Traefik Enterprise into the chat. And we are also going to send you the free trial link after the session, as well as the recording. So exactly. So now you can visit traefik.io/try and you can get yourself a trial of Traefik Enterprise and play with that 2-layer of traffic. And basically, we've been able to show you how you can benefit from that traffic provider in order to seamlessly send the existing traffic configuration from Swarm and Kubernetes, or from Kube and Kube, or from VM and Kube, for example. I mean, no matter what is the platform or the infrastructure that you are using, the idea is really to bring those configurations dynamically to another level, so you can manage the routing in an easier manner. And we have also mentioned the fact that you can use the API keys, which is a new feature in Traefik 2.5 in order to to manage the authentication using that keys. So this is also something new. And yes, and here we are. So big thanks, Matt, for your great presentation and great demo today. And we'll follow up with an email with the record, the trial, and more information. Thanks everyone for tuning in, and have a good day. Bye bye. Thank you.
Thanks everybody. Bye.